This is Mrs. O'Neill for AP Chemistry, Chapter 20, Section 1, Electrochemistry. Be sure to look over those key terms on page 864. We are surrounded by an amazing array of portable electronic gadgets, including cell phones, portable music players, laptop computers, and gaming devices. In the absence of batteries, however, our electronic gadgetry would be nothing more than extra weight. Thus, a variety of batteries of different sizes, compositions, and voltages have been developed. So in this case, we're going to review in Section 1 oxidation states and oxidation reduction reactions. This is actually a review of Section 4.4. So your objective is to review those oxidation states and redox reactions. Here you should pause, fill in the words, and then play to hear my voice. Electrochemistry is just the study of the relationship between electricity and those chemical reactions that take place. So first you need to assign oxidation numbers to every single element. And remember, oxidation numbers are the same as the charge numbers. Why do we need to do this? Because we need to keep track of those electrons in our redox reaction. So what's the difference between oxidation and reduction? Again, review from section 4.4. Oxidation is the loss of electrons. In other words, you're increasing that oxidation number. Reduction is gaining of those electrons, and you're decreasing that oxidation number. So remember, we talked about 3 different ways that you can memorize this. So you can do Leo the Lion Went GER. Reducing agent is oxidized. Of course, it's going to help you be oxidized. The oxidizing agent is going to be reduced. Again, the agent is always helping doing the reducing. Or you want to know oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. Or, and this is my favorite that I found, box. The oxidation number gets bigger, so it's being oxidized. So I like to remember box. Oxidation number, charge number getting bigger. That means it's being oxidized. An agent is just the substance that is causing the other one to be oxidized. Okay, so the oxidizing agent is really the reducer, and the reducing agent is really the oxidizer. So this is a way to remember. Real estate agents help others acquire property. Or insurance agents sets other people up with insurance. So an agent is going to help the other person do what it needs to do. The bursts of bright white light produced by fireworks are the result of metals being burned. Powdered or flaked aluminum or magnesium are included in the fireworks. When these metals are heated to high temperatures in the explosion, they burn with an intense white light. The fireworks shown here are called stars. As elements burn, their oxidation numbers change. In this section, you will learn about how oxidation and reduction are defined in terms of a change in oxidation number. So first thing is first, you need to be able to assign every single element in that reaction an oxidation number or a charge number or an oxidation state. They all mean the same thing. You can read over this, but most of this you already know, right? Elements are 0. The ions are the charge of their ions. Here we have that oxygen, and remember those peroxides or superoxides are weird guys, but those are ones that are things just to kind of keep in the back of your head. But for the most part, oxygen is always going to be -2. We want to remember that there is such thing as an H-1 as a hydride, and you want to remember that compounds are always equal to 0. As far as their overall charge, and then in polyatomic ions, it's always easier to equal to the charge of that polyatomic ion. And for binary compounds, that means a compound with only 2 elements. The more electronegative element is negative. And we want to remember that with most compounds, there is only one negative oxidation number. If there's 3 or 4 elements in a compound, there will be multiple positive, but usually only one negative. Not all the time, of course, there's always exceptions to that rule. So let's do an example for MnO4-1. How would we find manganese charge? Well, again, we're going to set it up like this. We know that oxygen is -2 charge automatically, so we're going to assign that manganese an X. So X minus the 4 times -2 to give us that -8 equals that -1 overall. Then you're going to do a little bit of algebra, and X equals +7. Remember, manganese is one of those transition metals that can be many, many different elements, so that's the easiest way to figure it out. So let's do another example of CO2. Here we have carbon dioxide compound. See if you can figure out the charges of the carbon and the oxygen. Again, that one's pretty easy. Oxygen is almost always -2, but in this case, carbon is going to be +4 because the overall charge is 0. How about example 2? Again, S is +6 because of crisscrossing backwards. So F must be -1 because a +6 minus 6 overall for fluorine would be a 0 charge altogether. How about example 3? Can you find the charge of your nitrogen and oxygen? Again, here would be one of those algebraic expressions that you'd have to use. And how about NO2 -1? Again, the charge of nitrogen is going to be different. Same setup here. And the charge is +3 this time. So lots of practice problems. It is up to you how you want to do it. Here I believe I have every slide 5 in groups of 5, so you could do the 5 and then pause and make sure that you are on the right track. But now I'm just going to kind of cycle through. Not sure there's going to be too many words that I'm going to need to say. And as you notice, I also did give them their names. So if you did not name them, that's fine, but you might want to do that in your head. Again, just to constantly remind yourself of what these, especially the polyatomic ions and the acids, making sure you know what the names of them are. So here again is another 5 if you want to pause and try them out before you see the answers. There's your answers. And again, hydrogen almost always is +1. In this case it is, but not all the time. Here in number 9, it would be a hydride because BH4 is a polyatomic ion on its own. But again, there's only one negative. So carbon is more electronegative, and that's why that carbon gets that negative instead of the hydrogen. Here's another 5. And hopefully that makes sense, and hopefully you even try to name those compounds or polyatomic ions. For this guy, I have a little bit more detailed explanation. You might want to read over that. And again, looking at CH4 versus C2H6, here we have, again, carbon is your more electronegative, so it's going to get the negative, where the hydrogen is the +1, even though it's written in that weird way. Again, back to organic chemistry. Here's 4 more. Hopefully you got that. Hopefully it is getting easier. Again, notice these all have 3 elements in their compound formulas, and only one of them is going to be a negative charge. And in this case, all of the oxygens are -1. It is the chlorine that you got of, at least for 16, 17, 18, the chlorines are going to be different in those different polyatomic ions. A few more here. And hopefully you got that. Ooh, there's nickel too. Remember those Roman numerals for those metals that have multiple charges. Ooh, another explanation for this guy. Yeah, this is another tricky one. This one actually has 2 negatives, and the reason being is because we can break it up into 2 polyatomic ions. So each of those polyatomic ions has a negative charge. Again, something that you're not going to see very often, but you just never know. So I wanted to at least give you some of that attention, give you that example, so that if you do see something weird on the exam, at least you've been exposed to at least one time. Okay, see you in class.